Well, hello everyone, and welcome to Prep 3.1. So in this prep, we're going to explore probability, and then we're actually going to end with the normal distribution and some interesting things that you can do with the normal distribution in probability. We'll also look at games of chance along the way, which should be interesting because it's very much in the news. Okay, so first we'll start with two definitions of probability. One is the empirical probability, which is the number of times an event occurs divided by the total number of observations. Sounds very scientific. And then classical probability, where you look at the number of favorable outcomes and divide that by the total number of possible outcomes. So here we have for this first problem here, we have some student survey results. The number of accounting majors, finance, etc. We'll go ahead and total those up. And then answer these questions. A survey of 39 students at Ohio University College of Business showed the following majors. Suppose you select a student and observe his or her major. What's the probability he or she is a management major? Okay, so management major, there's 8 of them out of 39 total. So it's going to be equal to 8 divided by 39. And which of these two definitions of probability did we use for that? Well, it sure looks like empirical probability. And it is. Okay. A large company must hire a new president. The board of directors prepares a list of 6 candidates, all of whom are equally qualified. 2 of these candidates are members of a minority group. To avoid bias in the selection of the candidate, the company decides to select the president by lottery. And so the question is, what is the probability one of the minority candidates is hired? Well, in this case, we're looking at classical probability, right? Because we actually have a favorable outcome according to the problem, which is the favorable outcome would be a minority candidate. But it's going to be done fairly by lottery, so we'll see who wins. And so how many minority candidates are there? 2. How many candidates total? 6. So it's going to be equal to 2 divided by 6. So that's basically a third probability the minority candidate will be selected, and that is classical probability. A sample of 50 natural gas industry executives was selected to test a questionnaire. One question about environmental issues required a yes or no answer. 10 of the 50 executives responded yes. Based on these sample responses, what is the probability that a natural gas industry executive will respond yes? So that's 10 out of 50. And that is empirical, because we're not leaning towards one or the other. Okay, so that's just a warm-up. Now let's keep going. All right, here we have baseball teams, and this is from 2012. Baseball teams and associated data, team wins, and attendance. We're actually looking at 2 factors, how many wins they had in the season and what their average attendance was. Well, not average attendance, total attendance was across the entire season. Okay, so on this dimension we have the winning season, and on this dimension up here we have the attendance. The winning season is just, yes or no. The attendance is broken down into 3 groups: low, moderate, and high. So now in this contingency table, we need to use the COUNT-IF to count the number of teams that fall into each of these categories. So COUNT-IFs, first we'll start over here with the winning season. And that's going to be, is it less than 81? And we need to freeze the column because we're going to be dragging this to the right. So Command T a couple of times, or F4, just to freeze the column there. All right, and now we look at the second dimension, which is attendance. So here we could kind of get away with not considering the other alternative because there's only two. But here we're actually going to have to consider both bounds, lower bound and upper bound. So we're looking at attendance. And we want it to be greater than or equal to 0, which is this one. And remember, we're going to lock, in this case, the row. And we want that same attendance to be less than or equal to 2, and also lock the row on that. So that was a lot. And go ahead and close the parentheses, and we get 4 teams. And then we should be able to copy this down and then across. All right, but I've left the totals out, so we'll use the sum function for those. Let's start here. And let's see if we can copy those. Having trouble doing the copy part. Oh, let's first take the sum function, then we'll copy it. All right, and then I need to, don't worry about that being a 0, it's just because I haven't done this one. Equals sum, and add these up, and then should have it. There you go. All right, but these are showing as raw data. These questions down here are going to be easier to answer if these are shown as percentages. So what we're going to do for each one is just convert it to a percent of the grand total. So this is equal to this number divided by the grand total. And we have to lock the grand total because that doesn't change, but all the numbers we compare it to do. And then we'll simply copy that all the way down. There. Okay. So now let's go ahead and answer these questions. Compute the following probabilities. A team chosen at random had a winning season. All right, so team chosen at random winning season. So here's winning season. It's this line. It's the yes line. And that would be over here, it would be the total, right? So it'd be 56%. So we can just put equals the 56.7%. So first we're going to do this sort of just intuitively, and then we'll look at the rules and the equations to kind of make it a little more academic. A team had low attendance or high attendance. Okay, so if they had low attendance, it would be this 23.3. They had high attendance, it would be 30, so we have to add those two up. So it equals 23.3 plus the 30. All right, a team had a winning season or attendance of more than 3 million. So did they have a winning season? Would be this one. And attendance more than 3 million would be this one. So it's equal to this one plus this one. And let's see what happens with that. That's wrong. The value is too high, and the question is why. And the reason is because we're not considering the overlap. So we have to subtract out the overlap, which is this number here. So it's minus the overlap, and we get 63.3%. All right, now let's go back and look at a couple of these rules, and then we'll finish up. All right, so what's the rule? This first one is just going to be a simple direct calculation. One would think. Let's see, maybe not. Team winning season. Maybe empirical probability, right? Because it's the number of wins divided by the number possible. So empirical probability, a team had low attendance or high attendance. That's going to be the special rule of addition. And so the special rule of addition is when the events are independent. And then a team had a winning season or attendance of more than 3 million. It's also going to be a rule of addition, but this is going to be the general rule of addition. All right, so now let's look at what's going on here. And we can look at this chart to help us. Okay, so empirical probability, the equation is going to be just what we did, number times the event occurred, remember from the prior tab, divided by the total number of observations. And then for the special rule of addition is going to be down here, right? Because the events were mutually exclusive, and it's just going to be probability of A divided by the probability of B. Sorry, plus the probability of B. Probability of A plus probability of B. So, and then for the general rule of addition, you have to subtract out the overlap when the events are not mutually exclusive. And so in the general rule, we have to do the one that subtracts out the overlap. The overlap is the probability of A and B together. All right. Now, if a team had a winning season, given that attendance was more than 3 million, right? So you've got attendance. So you know you're in this column here, the high attendance column, the 30. And then there's the winning season, which is the 23%. So basically, we're looking at, for the high attendance column, what percentage of those had a winning season. So it's really these two numbers here, the 23 and the 30. So it's equal to the 23 divided by the 30. And that's the key word here is given, right? So when you have the word given, then it's a conditional probability, which is represented symbolically by these vertical lines that you see here. See the vertical line? And so that's going to be one of the rules of multiplication. Oh, sorry. These things really are tricky. Sorry, conditional probability. I just said that and then I didn't do it. So it's conditional probability, okay, which is, it's just that given that, two things. And there it is, conditional probability, probability of B given A. All right, the team has a winning season and attracted fewer than 10 million fans. So winning season, fewer than 10 million fans would be this 10%, so we can just point to it. But that number itself was constructed by a direct calculation, of the two numbers being divided to get the 10%. And then the equation for this one this one's going to be tricky. Let's experiment. It's not that. It's that. Okay, so it's the probability of A and B. Right, and there's the and for the probability of A and B. All right, now we can do the same thing, and that's what you notice these two questions are identical, but we can get at exactly the same thing with a more complex calculation. Why you'd want to do that is questionable, but sometimes we're trying to understand the differences. All right, and so the one that we're after in this one is going to be, try to do this from memory, yeah. It's the probability of A and B again, see, here. Here we did it through direct calculation, but here now we're going to get the probability of A and B using the general rule of multiplication, which is this one here. And that's because they're independent events, and it's the probability of A and B. So now we're going to look at the probability of A times the probability of B given A. Okay, so the way that we're going to calculate this one is we're going to look at the probability of a winning season first. There's the winning season. Times the probability of low attendance, this one, given that it's a winning season. And we end up with the same 10%. Okay, we'll pick up again in the very next video with the rest of the tabs.